Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P050B, indicates a cold start ignition timing control system performance problem in the Honda HRV model years 2016 to 2022. This issue could arise from problems in the ignition timing control system, potentially affecting engine performance, particularly during cold starts. The failure may manifest when the vehicle's engine control module, ECM, detects that the ignition timing is not within proper parameters during the cold start phase. This DTC is crucial to address, as improper ignition timing can lead to increased emissions, poor fuel economy, and engine stalling. Proper component assessments and replacements are necessary to ensure optimal engine performance and compliance with emission standards. Understanding the implications of this DTC will guide subsequent diagnostics and repairs. The DTC P050B relates primarily to the cold start ignition timing control system and encompasses components like the engine control module, ECM. The ECM is responsible for managing the engine's ignition timing during different operational conditions to ensure optimal function and efficiency. This system utilizes inputs from various sensors located in the engine compartment, including the engine coolant temperature, ECT sensors. These sensors monitor the engine temperature and provide essential data to the ECM to adjust ignition timing accordingly, particularly during cold starts. A malfunction in any of these components can lead to the activation of the DTC P050B. Therefore, ensuring that the ECM and its associated sensors are functioning correctly is vital for cold start performance. The potential causes for DTC P050B can vary, but some common suspects include ECM software issues, malfunctions of associated sensors, and poor electrical connections. If the ECM software is outdated or has a glitch, it may not properly adjust ignition timing based on input data. Furthermore, if the sensors, such as the ECT sensor or crankshaft position (CKP) sensor, are malfunctioning, they may provide incorrect readings, leading to improper timing adjustments during cold starts. Lastly, poor connections, whether due to corrosion or wear, may disrupt signals between the sensors and the ECM, exacerbating the cold start ignition timing issues. Addressing these causes is essential for effective resolution of the DTC. The symptoms associated with DTC P050B can significantly impact the drivability of the Honda HRV. Drivers might notice a rough idle when the engine is cold, as the ignition timing may not be calibrated correctly. This irregular operation can be exacerbated by increased emissions, as improper combustion often leads to unburnt fuel being expelled through the exhaust. Another critical symptom is engine stalling, particularly immediately after a cold start, which can pose a substantial safety risk. Recognizing these symptoms can help in efficiently diagnosing and addressing the root cause of the DTC P050B, as they directly link to the operational efficiencies of the engine during cold conditions. In the first troubleshooting step for DTC P050B, start by turning the vehicle's ignition to the on mode without starting the engine. This action activates the onboard diagnostic system, allowing you to use the Honda Diagnostic System, HDS, to check for any pending or confirmed DTCs. Pay attention to whether any other DTCs aside from P050B are present. If there are additional DTCs, the next step is to proceed with the troubleshooting process for those indicated codes, as they could be related issues affecting the cold start ignition timing system. If no other DTCs are found, proceed to Step 2 for further diagnostics specific to the P050B issue. In step 2 of the troubleshooting process, you will perform a visual check of the intake air duct. This duct plays a critical role by directing the air needed for combustion into the engine. Start by inspecting for poor connections at the duct, as any loose connections can lead to inadequate air supply. Additionally, check for possible blockages within the duct that might restrict airflow. It's essential to resolve any such issues since insufficient air can directly affect ignition timing and subsequently engine performance. If the intake air duct inspection is found to be satisfactory, you may proceed to step 3, focusing on the air cleaner housing. In this step, check the air cleaner housing for any visual issues that could affect performance. The air cleaner housing filters the air entering the engine and is crucial to the proper mixing of air and fuel for combustion. Inspect for poor connections or blockages that could hinder airflow. If the housing is found to be compromised, it can lead to improper ignition timing and fuel efficiency issues. Should you confirm that the air cleaner housing is in good condition, move on to step 4 that involves examining the air cleaner element inside the housing for dirt or debris, ensuring that the engine receives unimpeded airflow. Next, in step 4, you will analyze the air cleaner element for signs of dirt or debris. A clean air cleaner element is vital for maintaining optimal engine performance, particularly since accumulated contaminants can significantly restrict air intake. If the element appears dirty, it should be replaced immediately to restore proper airflow. Should the air cleaner element be clean, you will then proceed to step 5, which emphasizes the verification of problems related to ignition timing performance by observing engine coolant temperature. In step 5, you will need to let the engine cool until the engine coolant temperature ECT sensor 1 reads 122 degrees Fahrenheit or less. This is essential because cold start ignition timing issues can only be accurately assessed in a cooled down state. Once the engine has reached the specified temperature, clear the DTC P050B using the HDS. After that, start the engine and allow it to idle for over 10 seconds to gather performance metrics. Finally, monitor the OBD status for DTC P050B within the HDS. If the status indicates a passed condition, this suggests that the system is currently functioning well at that time. However, if it shows failed, you should proceed to step 6 for further diagnostics. In step 6, assess the ignition timing within the engine. This step is critical because the ignition timing must be aligned with manufacturer specifications to ensure proper engine operation and efficiency, especially during cold starts. If the ignition timing is found to be okay, advance the process to step 8, where the throttle body will be examined as another potential factor affecting cold start performance. However, if the ignition timing is incorrect, continue to step 7 for further investigation into the crankshaft position, CKP sensor, and its associated components, which could be leading to the P050B error code. Step 7 involves a critical inspection of the CKP sensor and the CKP pulse plate. The CKP sensor monitors the position and speed of the crankshaft, allowing the ECM to adjust ignition and fuel timing. Look for damage or loosened connections, which could affect its functioning. If the CKP sensor or the pulse plate are found to be faulty or loosened, they should be replaced immediately to restore the necessary timing signals. If both components appear to be in proper working order, you may need to consider an update for the PCM software, or substitute it with a known good PCM to confirm whether that resolves the P050B issue. In step 8, select the ETCS test option from the HDS inspection menu. This test is essential to verify the status of the throttle actuator control valve, which plays a key role in managing the engine's air intake. If the actuator is found to be functioning normally, You can proceed to Step 9 to check the mass airflow MAF sensor to ensure that it is providing accurate data for engine management. Conversely, if the throttle body is not operating as expected, replacement of the throttle body will be necessary to resolve issues related to the cold start timing. In Step 9, the engine should be started and held at approximately 3,000 RPM in a no-load condition while closely monitoring the mass airflow MAF sensor values through the HDS. The MAF sensor is critical for determining the volume of air entering the engine. It's vital that its readings align with specified threshold values, which are between 4.9 and 6.9 grams per second, G per second. If the current conditions match these thresholds, the MAF sensor can be deemed functional and you may proceed to Step 10. However, if the readings deviate from this range, replacing either the MAF or the intake air temperature IAT sensor may be necessary to correct the cold start timing issue. In the final troubleshooting step, turn the vehicle off and allow the engine to cool down to ambient temperature before proceeding. After cooling, re-engage the ignition to the on position and quickly check the values of both ECT Sensor 1 and ECT Sensor 2 using the HDS. It's crucial that neither sensor deviates more than 5.4 degrees Fahrenheit or 3 degrees Celsius from the ambient temperature. If one of the sensors does exceed this threshold, you will need to replace that sensor. Should both sensors be functioning correctly, ensure that the associated components and wiring are in well condition. If the sensors and wiring are satisfactory, updating the PCM or substituting it can be the final steps to ensure the DTC P050B has been accurately addressed. After completing the troubleshooting and any necessary repairs, the final verification process is essential for ensuring the efficacy of the work done. Begin by confirming that DTC P050B has been cleared from the system using the HDS. Following this, conduct a thorough test drive to evaluate the performance of the vehicle under various conditions, especially focusing on its cold start behavior. While driving, monitor engine performance closely, checking for any signs of rough idle, stalling, or emissions fluctuations. If the vehicle performs as expected without the reactivation of DTC P050B, you have successfully resolved the issue. The confirmation of repairs solidifies the reliability and safety of the vehicle. Preventive maintenance plays a crucial role in maintaining optimal performance and longevity of the vehicle's ignition timing systems. To limit the occurrence of issues associated with DTC P050B, regularly inspecting and replacing the air filter is essential to ensure that the engine receives clean airflow. Attention to all wiring connections can prevent problems arising from corrosion, wear, or poor connections, which can impact signal transference within the ignition timing control system. Furthermore, ensure that the software for the engine control module, ECM, is regularly updated to incorporate improvements or fixes from the manufacturer. Adhering to these maintenance practices will proactively reduce the likelihood of future cold start performance problems. In conclusion, DTC P050B highlights the importance of timely diagnostics and effective troubleshooting of ignition timing issues, particularly during cold start conditions. By understanding the roles of critical components such as the ECM, ECT sensors, and CKP sensors, technicians can efficiently pinpoint problems affecting engine performance. The structured approach to troubleshooting ensures that each potential area of failure is examined thoroughly. Moreover, proactive preventive maintenance practices are pivotal in maintaining vehicle performance and avoiding future complications. By remaining vigilant in inspections and adjustments, drivers can ensure their Honda HRV operates at its best, regardless of the weather conditions. Please like and subscribe to the channel. See you next time.